Hey guys, it's Miss Johnson and I'm here to bring you our third notes video for Unit 5. This is on the quadratic formula. So our learning target for today is I can solve quadratics using the quadratic formula. So we're just going to practice up at the top a little bit of review with using the square root sign, this radical sign that we have here. When we're looking at something like the square root of 16, we're looking for what number times itself gives me 16, and that number would be 4. So I'm looking at positive 4 here. When I'm looking at the negative square root of 25, the square root of 25 is 5, but I want the negative version of that, so I'm looking at negative 5. If I look at the square root of 34 minus 2 times 3 times 3, I know that I need to simplify what's underneath the radical first. And even within that, it's kind of like this radical sign puts parentheses around these. But even within those parentheses, I've got some multiplication that I have to take care of. So if I simplify that first, I have 2 times 3, which is 6. 6 times 3, it gives me 18. So I have the square root of 34 minus 18. And then 34 minus 18 is 16. So I have the square root of 16, which again is 4. So moral of that story is simplify what's underneath the radical first, then take the square root. In this next one, number 4, I have the plus or minus square root of 49. That's what that symbol means if you need to write that down. It's red, plus or minus. Literally, it's the plus sign and the minus sign put together. So plus or minus the square root of 49. So square root of 49 is 7. That means I'm looking at it positive or negative 7. This is really two answers here. Two values. Our two values are positive 7 and negative 7. Let's take a look at number 5. When I take a look at number 5, I'm back to those multiple things underneath the radical sign again. So I'm going to start by simplifying this 4 times 2 times negative 2. 4 times 2 times negative 2 gives me a negative 16, but I'm looking at a negative 4. So I really have a positive 16. So this is like saying 3 squared plus 16. I had this negative times that negative, which gave me a positive 16. 3 squared we know is 9, so really I have 9 plus 16, which is the square root of 25, which is equal to 5. Now let's look at the next one, number 6. In number 6, I have a radical with all this stuff underneath, and then I have this negative 7 minus that radical out front. I have to simplify the radical first. Like I said, a radical sign, or a square root sign as we've probably called them in the past, that's what this thing is called. A radical sign is a grouping symbol. It groups everything that's underneath together. So I have to do underneath the symbol first. I can do it in pieces, so I'll do a couple parts here. So I have negative 5 squared, and negative 5 times 5 is 25. And then I have negative 4 times 1 times times positive 4. Negative 4 times 1 times positive 4 is negative 16. So I'm looking at 25 minus 16 there. I still have this negative 7 minus that whole thing out front. Now I keep simplifying under the radical. That's negative 7 minus the square root of 9, because 25 minus 16 is 9. And then take the square root, negative 7 minus 3, square root of 9 is 3, and I'm left with a negative 10 there. Okay, and then in number 11, bunch of stuff under the radical first, so let's take care of that. I would have the square root of negative 7 squared is positive 49, then minus 4 times 5, which is 20, times another 2, which is 40, so minus 40. I still have this 11 plus or minus out front. So that's 11 plus or minus the square root of 9, because 49 minus 40, and that's 11 plus or minus 3. So here's how we answer this. I have two answers here. I have one that's 11 plus 3, which is 14, and I have another one that's 11 minus 3, which is 8. I literally split this into two answers because I had the plus and the minus. So I have two answers here, 14 and 8. All right, so now all of that is just practice of order of operations for something that we call the quadratic formula. When we are using the quadratic formula looks like this. It's a big, long, lengthy formula Looks like that. I'll read it out loud to you so you know how it's read. It says x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, what I want you to do for fun, because math is fun, woohoo, is hop on YouTube at some point and search the quadratic formula. You're going to get some crazy fun videos and songs that help you remember this whole big long thing, okay? This is a really long formula. I totally agree with you on that. This is a long formula. It's a lot to memorize. However, the beauty of the quadratic formula is that it works every single time. We can use the quadratic formula with every single quadratic equation that we come across if we are trying to solve it. We have other methods to solve. We can solve by graphing and we can solve by factoring. We solved by factoring back in Unit 4 when we used that zero product property. But those things only work when the graph turns out nice and when the equation is factorable. Sometimes the equation is not factorable, or sometimes you end up with some funny decimals and then you can't see them on a graph. The quadratic formula will work for you every time. So that is why we love it. It works for you every time. So now let's just talk about what that quadratic formula is. It solves quadratics to find the roots or zeros or solutions. Those are all different ways of just saying solutions to the quadratic. We have to have our quadratic equations set equal to 0, and this can be used in place of factoring or graphing, because we use graphing sometimes to solve too, like we did in notes 1 of this lesson of this unit, to solve quadratics. All right, so now let's talk about how we use this bad boy. Solving the quadratic formula really is kind of mindless. You find the a, the b, and the c. We all know how to do that. We plug our a and b and c into the formula, and we simplify. Whatever our answers are, we're going to round them to 2 decimal places if they are decimal answers. Okay, this is really just simplifying an equation. It's a long equation, but it's just simplifying. It's really mindless. That's the nice part about this. Okay, so let's do some examples. In number 1, I have 3t squared minus 7t minus 20. So if I plug this into the quadratic formula, I want to solve this using the quadratic formula, so I'm going to plug it in. I know that my a value is equal to 3, my b value is equal to negative 7, and my c value is equal to negative 20. Now, one of the songs that you'll learn for the quadratic formula goes to Pop Goes the Weasel. So if you hear me singing that, that's just because that's the song that I know, and that's how I use to remember it. So I know I'm plugging it in. I have x equals the opposite of b. B is negative 7, so its opposite is positive 7. Then plus or minus the square root of, that's b squared, put it in parentheses, minus 4 times a times c. And that is all over, oops, c is negative 20, there we go, all over 2 times a, which is 3. Okay, so now this is just what we practiced at the beginning. Now we got to go back and simplify. Start with what's underneath the radical first. So I take care of that first. Now you may type this all into your calculator, but make sure you put your parentheses in. Put all of these numbers in parentheses so that the negatives keep with the number that you want them to stay with. So when I type all of that in, I also can just look at this piece versus that piece. I have 7 on the outside plus or minus. Underneath the radical, negative 7 squared is 49, and negative 4 times 3 times negative 20 is positive 240. Okay, that's still all over 2a, and 2 times 3 gives me 6, so I can simplify that. Some of you may have just straight typed this whole thing into your calculator, which hopefully if you did, you ended up with an answer of 289 for underneath that radical. Okay, so 289 is what we get when we put 49 and 240 together. Don't forget to take the square root. That's a common mistake that I see people make. So I have x is equal to 7 plus or minus the square root of 289, which is 17, all over 6. Okay, when I get to the point that the radical is gone, I've simplified everything underneath, I've gotten rid of the radical sign, I've taken the square root. Now I'm ready to split it into two separate equations. I have one that is x equals 7 plus 17 over 6, and one that is x equals 7 minus 17 over 6. 7 plus 17 is 24. Think about that a second. 24 divided by 6, and 24 divided by 6 gives me 4. 7 minus 17 is negative 10 over 6, which is just negative 5 over 3. Okay, so those are my two answers. I have x is equal to 4 and negative 5/3. Now, a lot of people want to look at those answers and write them as an ordered pair just because that's what we've been doing a lot lately, especially like in systems we were writing a lot of ordered pairs. When we were graphing quadratics and finding the vertex, we were writing a lot of ordered pairs. These are not ordered pairs. These are two different solutions for x. This is just two different points that the parabola crosses the x-axis. That's what that means, okay? So keep that in mind. It's not an ordered pair. It's just two different values for x. Two solutions here. Let's try number 2. In number 2, I have f of x is equal to x squared plus 3x minus 18, and I want to solve it. Now, when I have a solution that is written in function notation, that's what this is. As long as there's no numbers over here, I can set this thing equal to 0 already and solve. That's all that f of x is just telling you, hey, this is a function notation. So I know that my A value is 1, my B value is 3, and my C value is negative 18. So let's plug it all in. I'm going to have x equals the opposite of B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. That's another piece that I see people forget sometimes. This is a big, long formula. It has a lot of parts to it. So make sure that you're writing down all of the parts. And by the way, you will have this formula when you take your final exam. You will be able to write this formula down. You don't have to have it memorized. It's good to have it memorized because it's going to make you go a lot faster. But if you don't, you can write it down. So let's go through and simplify this. I end up with negative 3 plus or minus, and then underneath my radical, 3 squared is 9. Negative 4 times 1 times negative 18 is positive 72. Negative times negative gave me a positive. 4 times 1 times 18 is 72. Denominator, 2 times 1 is just 2. Keep going, that's negative 3 plus or minus the square root of 81 all over 2. We all know the square root of 81 is 9, so I have x is equal to negative 3 plus or minus 9 all over 2. Again, once that radical is done with, once you've finished the radical piece, you've simplified everything underneath, and you've taken the square root, now you split it into the two different parts. X is equal to negative 3 plus 9 over 2, and x is equal to negative 3 minus 9 over 2. So when that happens, I have x is equal to negative 3 plus 9 is 6 over 2. That's x equals 3. Negative 3 minus 9 is negative 12 over 2. That's x equals negative 6. So my two solutions here are 3 and negative 6. Again, not an ordered pair, just two different values for x. All right, let's take a look at number 3. In number 3, I have 4x squared plus 2x is equal to 17. Now, this is a quadratic function. It is a quadratic equation because I have that x raised to the second power there, so I know it's quadratic, but it looks a little different. If I want to solve this, I have to have this thing set equal to 0. So if I have to have this thing set equal to 0, that means I need to get rid of this 17. So I'm going to subtract 17 from both sides, and that gives me 4x squared plus 2x minus 17 is equal to 0. Now that's a quadratic that I'm ready to solve. I have this equals 0 over here. I have the a, the b, and the c. A is equal to 4, b is equal to 2, c is equal to negative 17. So then I can solve it. Opposite of b, negative 2, plus or minus the square root of b squared, that's 2 squared, minus 4 times negative 17. all over 2 times 4. Simplify underneath the radical first. So 2 squared is 4. And then I know I have a negative times a negative, which is positive, which is why I wrote that plus sign in. So negative times negative gives me a plus. Then I have 4 times 17, which is 272. And you should be checking all of these with your calculator as we go so that you know you're typing them in the right way and getting the same answers I did. So I have x is equal to negative 2 plus or minus. 4 times 272 is 276. And then all over 8. Now I typed the square root of 276 into my calculator. It is not a perfect square. You're going to get a big long decimal here. This is why we say round your decimals to 2 places. So that's what I'm going to do next. I'm going to have x is equal to negative 2 plus or minus. I get 16.61 here when I round it to 2 places. Now I'm ready to split it apart. So now I'm going to have x equals negative 2 plus 16.61 all over 8, and x equals negative 2 minus 16.61 all over 8. So I end up with 14.61 all over 8. And when I type that into my calculator, that is going to be 1.83. Over here, x is equal to negative 18.61 all over 8, and x is equal to negative 2.33. So my two solutions here, you can just circle both of these separate. As long as you indicate to me that there are two solutions, that's fine. So I have the solution of x equals 1.383 and negative 2.33. All right, so I'm going to stop our first video at this point. If you want to take a break and start working on your practice assignment, you certainly may do that. Just come pick it up from me, and we can pick up with number 4 in our second video. Thanks for listening.